Alright guys, those of you that have a little extra time on your hands, here is how you walk through some of these problems here, okay? So the big idea a few years back was the whole NFL Deflategate, and talking about sports inflating sports balls. They do need to be within a certain weight in order to play. I referee soccer, and one of the things I had to always do was check the weight of a soccer ball before playing with it. So this is what the whole idea was about. And for an NFL game, a football should weigh it should weigh 13 ounces with a tolerance of 1 ounce. Okay, so that means it can either be plus or minus 1 ounce. It might weigh more, it might weigh less. Okay, it doesn't have to be perfect. Okay, same thing. It doesn't need to be perfect. Because I mean that's very hard to do. Same thing goes on assembly lines. Okay, a lot of things are let go plus or minus an inch or two or things like that. So write an absolute value inequality describing the weights of a football that should be rejected. Now I know you guys are bright enough to recognize, okay, well they need to reject things like, obviously you can't play with something that's negative, or that is negative. You can't play with a football that's like 11, you can't play with one that's 10, you don't want to play with one that's like 20, okay? But to write algebraically, okay, it's really not too hard. You're going to take your actual weight. Okay, so the referee, he's here, he's blowing up the football. The actual weight minus the target weight. Okay, and we know that our tolerance, it needs to be less than or equal to our tolerance. Okay, so here's our tolerance. 13 ounces is our target, and the actual weight, we don't know. Okay, we don't know exactly what it is. So when you don't know something, you use a variable. So the algebraic expression is simply x, absolute value, minus the target, which is 13, is less than or equal to 1. Okay, so some things you might want to write down, and this is if you're given tolerance. So tolerance, you need a few things. You need the actual weight, the actual, which is just your variable. You need your target, which will be given to you, and you need the tolerance, which will also be given to you. Okay, that's it there. We know it can't be any more than the tolerance. Okay, it has to be less than that. That's why the sign is going to be that one there. Now again, you can solve this, but that's it. So if you wanted, you can go ahead and you can solve it. Okay, what must you do when you see absolute value? You keep, and you flip switch. Okay, sorry about all those beeps. You keep one the same. X minus 13 is less than or equal to 1. X minus 13 is greater than, or equal to negative 1. You gotta flip the sign. And you add 13, you add 13, thing. So you cannot play with anything, obviously, that is 14 ounces, including or more. And you don't want to play with anything that is, let's see, plus 15, plus 15, 12. Okay. Like I said, you guys know how to do these here. That shouldn't be too much of a problem, I hope. Let's see what we're doing here. Right? Whoops. Good. Okay. So, actual weight, target weight, and tolerance. The next type is if you're given a range of values, okay? This one is just set up a little bit differently. So this time they're actually giving you kind of where the mat can be. So if we have a gymnastics mat, it must be between 7.5 inches and 8.25 inches. So if we have some gymnastics mat, here's my mat. Okay, we know that and it's inclusive, we know that it can be between 7.5, or maybe it's thicker. Maybe it is, that's like twice as thick, but we'll say 8.5, 2 pounds. Okay, anything within that range is good to go. So it's a little bit trickier how to do this one, okay? First, again, sorry about the beeps, it's my USB. You need to find the mean of the thicknesses. Well, if you remember mean, that's the same thing as the average, okay? And to do that, you'll take 7.5 plus 8.25. We have two numbers, so we'll divide by 2. And that will give you 7.875. Okay? And that is what we call the mean extreme. Okay, the mean upper extreme. Okay, so from there we are going to subtract the mean upper extreme from the actual, so this is the mean extreme, and we're going to subtract it from the upper. So this was our upper bound, and we can think of this as our lower bound. Alright, lower, upper. So we're going to subtract from the upper extreme. Here's the mean, okay? So you simply take our 8.25 and we'll subtract our 7.875, and that gives us our tolerance of 0.375. So you need to find the average, and then you subtract from the upper extreme, and that's our tolerance. Now we have our target and we have our tolerance just like before. So here is our target, 7.875, our mean extreme. That's your target. Alright, and just like before, once you have your target, we're going to take our actual minus the target, and it's going to be less than or equal to the tolerance. center equal. Our target is the mean extreme. Mean extreme equals target. 7.875. And our actual, we do not know, is X. Okay? I know that is probably tricky to go through the first time. Try maybe to look back and do it slowly again. So 1, you find the average. 2, subtract from the biggest number. That's your target. Subtract from the biggest extreme. That's your tolerance. And then write out. Okay? Again, I'm not asking you to be a pro, but hopefully you at least see that and you can respect that, and you should be able to at least give a shot to 59 and 77 now. Again, use the textbook to help you out. Bring these questions to class. Be like, hey, Mr. Dvorsky, can we do more types of these problems? I will say, absolutely, yes, I love the challenge, and that's what you should be doing. So thanks for hanging out a little extra. Maybe I'll give you guys some Dvorsky dollars for your time spent. And we will see you tomorrow.